was thinking, in life, it pays to be safe, especially like at your job or just enjoying yourself at home. It always pays to be safe. If somebody catches you at your job being unsafe, chances are you're going to get a stern talking to, might even lose your job. And at home, if you're unsafe, that could result in something more serious. It really depends on what you're into, I guess. So I decided I'd wind my own coil here, and I'm going to make myself a little Tesla coil. See how it turns out. Experiment with resonance. The problem with that is your power supplies generally run at a pretty high voltage, and it's very dangerous. Regardless, the spark looks really cool. So all we can do is be as safe as we can, see if it works. A lot of the safety equipment for on-the-job electrical work is similar for electrical work like building a Tesla coil. I don't assume you'd see it much at work, but I mean, I don't know where you work at. I just finished my primary coil side capacitor. It's pretty much 3 1 nanofarad capacitors in series, and 3 of those in parallel to hopefully bring it back to 1 nanofarad. When you stack capacitors in series like that, it ends up lowering their capacitance value. But the reason people have to put them in series like that is because they're only rated for 20,000 volts. And I want a 60,000 volt rated capacitor. So I gotta put 3 in series, and now it's pretty much rated for 60K, 1.04 nanofarads. That is gonna go like that, or something like that. This is gonna attach to the neutral of the high voltage source. Wait, yeah, that's right. Then there's going to be a spark gap from here to here as this cap charges up. Wait, that'll be hooked onto this side of the cap. The spark gap's going to be this side of the cap to here. As it charges up, that's going to spark, short the primary winding here. It's going to resonate at the resonant frequency of this cap and this primary coil. And the secondary coil without a top load I've calculated to be pretty similar in resonant frequency. They're off by a factor of about 100 kilohertz, which is not bad considering the primary resonates at 2000 kilohertz, the secondary at 2100. This should allow for whatever capacitance is generated by arcs coming off of the top of the secondary to detune the secondary a little bit and lower its resonant frequency, and it should resonate at pretty near to the primary's resonant frequency. But we will see once testing comes around. Still have to figure out how I'm going to ground the secondary. That'll be in step 2.